Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is node to root path in a binary tree. Okay, so in this question we have to find the node to root path from a binary tree. Okay, so we have already discussed this question in the level 1, and we have done that particular question with using some another method. That is, we have passed one array list here in the argument, and then what we are going to do is we are just filling that array list, and our return type was void type. But now what we are doing is we are using return type of array list. So what we are doing is we are filling that array list, and then we are returning it here only. Okay, so the only difference is simply this, like in that case we are not returning the array list, we are simply just filling it from the argument, and now in this case we are filling it here and we are returning it also. So this is going to change our flow of a recursive code. So let's see how can we do this. So first understand what are the node to root path of any particular data. Suppose the data is 5. Okay, so what is the node to root path from fifth node? Okay, so for this, how can we do this? We are going to search the 5 here. So first I'm going to search it. Suppose this is our 5, and now we have to reach to the root element. Okay, so how we are going to do this? So first I'm going to visit 5, then 9, then 7, then 2. So this is how we can reach to the root element. Suppose let me change some another value, that is data is equal to 11. Suppose our data is now 11. So how can we reach to the root from 11? Suppose this is our data, this is our destiny. How can we reach here there? By just simply first I will go 11, then 9, then 7, then 2. So this is the path actually. Okay, so what we have to do, we have to fill this path, that is 11, 9, 7, 2, and then we have to return it in our function. Okay, so this is actually the question, what question is talking about. Okay, so let me remove this. So first what I'm going to do is, first I'm going to implement one find data function, and then with the help of this function I'm going to reach to this particular function. Okay, that returning of array list. Okay, so we have already implemented this function in our last node to root path video. Okay, so again I'm going to implement the same function, and what this function does is this find data function. This is actually the boolean return type. Okay, so if we are able to find this particular data in the tree, then it is returning true, else what it was doing, it was returning false. Okay, so this is actually the basic idea of this particular function. So let's go and code this function out. So first I'm going to do this full screen, and let me do it now. So what is the name of function? So public static boolean, the return type is boolean, and the name is find data. Okay, so for this I'm going to pass the tree node, and then the second argument is data. Okay, so how first I'm going to check it whether the node is equal to null. That means we haven't found the data yet. Okay, so what we have to return, we have to return false. Okay, we have to return the false over here. Then again I'm going to check for the second condition, that is the node of well is equal to data. So what this condition is checking, that I'm going to check whether this value is equal to data. If in this case we have found the data. Okay, simply what we have to do, we have to return true, that we have found the data. And in the end I'm going to use the both two calls, that is left call as well as right call, and I'm going to take the OR operation. So what is the left call? That is node dot left of data. And what is the right call? That is find data node of write data. Okay, so this is the right call. So if any of this condition is true, then we are going to return true over here. Okay, so let's see how this code is flowing. So let me take this code and let me dry run this. Okay, so we are going to check the flow, how this code is flowing. Okay, this is our code. So first I'm going to implement, create one stack. Okay, so this is our stack, and now I'm going to see the flow. So first what is happening is, first it is checking. First, now the root node is here. Okay, first it is going to check this, whether the node is null or node is equal to data. Okay, so these two conditions first we are checking. Then we are going to use the left call if both the conditions are false. Okay, so these both the conditions are false, so we are going to reach to the left side. So I'm going to put 2 of left. Okay, then again these both conditions are false, then we are going to move to the left side, that is 7 of left. Again these both conditions are false, this is not null and this is also not equal to data, then again we are going to the left part. When we reach to the left part, we encountered the null. So if node is equal to null, then what we are going to do? We are going to return false over here. Okay, so we are going to return false. This condition is false for the third node. Then if this condition is false, then we are going to check for the second condition, that is for the right. So it is going to check for the right also. So again it will return false because this is null. Okay, so in the end what is going to return is, we have to return false. Okay, so false will return from the left side of 7. So suppose this is for the left seventh call, and we have completed this left part, that is false. Okay, so what we are going to do, we are going to check for the right. Okay, so how can we do this? So now we are moving to the right side. So let me update this. So this call is going to be the stack. Now we are going to the right part. Okay, now we are moving to the right part. Then again 9 is, these two condition is true. No, none of condition is true, so we are moving to the left part. When we will reach to the left part, that is fifth node, what is going to happen is, first it is going to check this is false, but now this condition is true. If this condition is true, so it is going to return the true over here. See, it is going to return true over here. And now you have to see something. See, it has returned true over here. So this is for the ninth call. Okay, so and we have used the left call, and from the left call it has returned true. So will there is a need for the right call? No, it is not going to check for the right, because this is a OR operator. If our first condition is true in case of OR operator, then it doesn't check the second condition, because now it is confirmed that we are going to receive the true. Okay, so for this it is just directly going to return over here. Okay, so first what has done is, first it was returning true from here, and now it will not check to the right side, it is going to directly return from over here, because now we have received true. So false or operator true, that is equal to true. Okay, so now for 7 we have received false from the left side, so we have checked for the right side and we received true over here. So again for 7 it is going to return true over here, and in the end we have already received the true from the left side, so it is not going to check for the right side also, because now 2 have received the true from the left side, so it 2 will not check for the right side. So in the end it is going to return true. Okay, so this is how our code is flowing. Okay, so you have to see this flow of the code. Okay, so let me erase this also. So now 7 left have returned true, and again 7 right has returned true, and 2 left has returned true. This is how the stack is going to empty. Okay, so now you have to see one thing. See, What is that thing? You have to analyze it. When you receive that fifth, when you receive that data, now you are returning from the path only. See, from 5 you have reached to the 9, from 9 you have reached to the 7, from 7 you have reached to the 2, and 2 you have terminated the this function. Okay, so if you are receiving that value, you are just simply, what you are doing, you are just simply returning from that path. So now how can we do this of return type of array list? You simply need to change the return type. Now it is a boolean, so for instead of boolean we are going to return the array list, and when we will found the data, then we are going to return we are going to fill node to array list and then return it. And if we are founding the null, then we are just simply returning the blank array list. And when we have used the left and right call, so if our left call array list is equal to 0, the size is equal to 0, that means we haven't found that data yet. Okay, so in that case we don't have to add the node. If the size is not equal to 0, that means we have already found the data. If we have found the data and if the size is not equal to 0, then in that case we have to add myself also in that particular array list, and then we have to return it. Okay, so this is how the code is flowing. The same is goes to the right side also. So let me do the code first, and then we will see how the code is actually flowing. Okay, so now it is little bit easy to implement this. So let me implement this first. Okay, so now let me change it. So first I'm going to change the return type from boolean to array list. So I'm going to return array list, and now I'm going to change the name also, find data node to root path. Okay, so this is our method name. So if we found the null, then what we are going to do, we simply return the blank array list. We will simply return the blank array list. But if we found the value, that means we have to create one array list. We are going to create one array list. So the condition is answer. So we have created one array list, and then we are going to add in the data into this, add data, and then what we are going to do, actually the array list is of type node type, so we have to add a node. Okay, and we simply return the answer. We are going to simply return this answer. Okay, and then we have to use the left as well as the right call. Okay, so for this, let me copy this. So node of dot left comma data, and we also have to receive it. Okay, in array list. So array list of pre-node, that is left call. So we have received it, and now what we are going to do, we are going to check the size. So if the size is not equal to 0, that means we have found our data. Okay, so if left dot size is not equal to 0, that means there is some node present in the left array list. Okay, so what we have to do, we simply have to add myself also. Left dot add, and I have to add myself, and then we have to return it. Okay, so then I have to add myself, and then we have to return it, and the exact same thing we have to do for the right side also. So I have copied this, and let me do this for the right. So simply I'm going to copy this node of right, and again I'm going to return the right, and I'm going to check for the right. I'm also going to add to the right side. Okay, and if these both conditions are false, okay, if the both left as well as right size is 0, then in that case we have to return the blank array list. Okay, so in that case we have to return the blank array list. Okay, so this is how we can do this. Now the last thing is we just simply have to call it from over here. So let me move here and return node and data. Okay, so let me check for all the compile time errors. So it is accepted. So let me dry run this. Okay, so let me take this code and now I'm going to quick dry run this so that you can connect with the last one. Okay, so this is our code. So I'm going to simply dry run this, quick dry run. So first, now I am here. So again, it is for null and it is for data. It is for null, it is for data. Both the conditions are false, so I'm going to move to the left side. Again, both the conditions are false. Again, I'm going to move to the left side. Again, both the conditions are false, so again I'm going to move to the left side. Now we have written the blank array list because node is equal to null. We have written a blank array list. Again, we have to check. Now we are going to check this. Size is not equal to 0. That means we don't have to. Actually, size is equal to 0. That means this condition is false. So we cannot add to the left side. So again, I'm going to use the right call. That is null. So again, we have to return blank array list. In this case also, the right dot size is equal to 0. Okay, so again it is going to add return the blank array list. So now in the end, from the 3 side, we have to return the blank array list. Okay, so we will return a blank array list. Now I'm going to right side. Okay, so for 7 we have received the blank array list, so it is not going to add the node over here. Okay, so now I'm going to check for the right side, that is for the 9. Okay, so for 9 both the conditions are false, then again I'm going to use the left side of the 9, and now we found the data over here. Okay, so when we use the left condition, so now the first condition is false and the second condition is true. If the second condition is true, it is going to create one array list and it is going to add himself and then it is going to return it. So now in case of 9, in the left we will receive one 5 array list. There we will receive one array list and in that array list there is one 5 node. Okay, and now the size is not equal to 0. In that case, what we have to do, we have to simply add myself also and we have to return it. Okay, now this condition will not be occurred. Okay, so now we cannot move in this code, we cannot move in this code, so we will simply return from over here only. Okay, so what I'm going to do, I'm going to add myself and I'm going to return it. Again the same thing is going to happen. So but in case of 7, it was the right call, that it was over here, and now we have received the 5 and 9 in the right variable. Okay, now the size is not equal to 0, that means we have to add myself and we have to return it. Okay, so now we are going to add myself, that is 597, and now we are going to return it to the second. Okay, so then for 2 we will be over here over the left and it will receive the 5, 9 and 7. Okay, so again the same thing is going to happen. We have to add myself, that is 2, and we have to return it, and our stack is now empty. So this is how the code is flowing. So let me run this and check for all the test cases. So let me run, we have already run this, so we have to check for the test cases. Okay, so now check for the test cases. Okay, so let me see this, and all the test cases are running fine. So guys, thank you for watching this video and we'll meet you in the next video.